Well, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions. And we'll try to get to as many as we can near the end of today's webinar. Also at the end of today's webinar, we are doing a drawing for 6 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 6 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which does include a demo. Today's webinar is Kubernetes at Datadog Scale. Our speaker today is Ara Pulido, who is the technical evangelist at Datadog. Hi, Ara, how are you? Welcome to today's webinar.
Thank you, Charlene.
So I know you have a great presentation on tap. I'm going to put myself on mute, take myself off camera, and let you get right into it.
Sounds good. Okay, welcome to this talk about how we scale Kubernetes at Datadog. This talk itself is not about Datadog, but just so you know, Datadog is a monitoring and analytics platform that helps companies improve observability of their infrastructure and applications, including, of course, monitoring Kubernetes itself, so the platform, and also the workloads that you run on top of Kubernetes. As Charlene said, my name is Ara Pulido. I'm a tech evangelist at Datadog. I've been working in Kubernetes projects for the past 3.5 years. I'm a certified Kubernetes administrator, and that is my Twitter handler and my email. So if you have any feedback or you want to reach out afterwards, feel free to do so. But this talk is about Kubernetes. And what is Kubernetes? Kubernetes is an orchestration platform that is completely open source for containerized applications. It was created originally by Google based on the ideas that they had on their own orchestrator called Borg. So based on those ideas over the years, they decided to create this open source project from scratch and give it to the world, basically. Now it has been donated to the CNCF as part of the Cloud Native Computing Foundation, and it's a super successful open source project. So to put some stats there, it has had 19 major releases since 2015, more than 90,000 commits from more than 2,000 contributors. So needless to say, it's a super big open source project and it's super successful as a community, as an open source project. But it's not only successful as an open source project, also for users. So this is the Google trend, just to put an example. This is the Google trend for searches on the Kubernetes terms in 2016 until more or less January this year. So as you can see, it's a trend that keeps growing and probably will continue growing in the next few months and years. So maybe when you saw this graph, you've seen the same thing that I saw when I was preparing this presentation, that it's we have some outliers on this trend. And one of the things that we like doing at Datadog is putting different metrics on the same timeline so we can find correlations on those metrics. And we know that correlation is not causation, but in many cases, it can help us find the root cause. So when I first saw this graph, I had a theory of why those outliers were there. And I wanted to confirm that. So what I did is to put on the same time frame, same timeline, Google Trend searches for Mariah Carey classic, All I Want for Christmas. And when I did, this is what happened. So as you can see, it's a exactly perfect correlation. Obviously, the root cause is the holiday season. People take time off work, and therefore they search less for work-related terms like Kubernetes. If correlation meant causation, it would mean that, I don't know, once a year, a bunch of people, we don't know why, they drop everything they have to do with Kubernetes to listen to Mariah. Could be as well, who knows? Okay, so The talk itself is about how we are using Kubernetes at Datadog internally, so for our infrastructure. But the first question to ask would be why we chose Kubernetes when we were deciding to moving away from our legacy infrastructure. And there were many reasons, but the most important ones were both technical and business related reasons. So on the technical side, one of the things that we loved about Kubernetes is that it's very extensible and flexible. Everything is API driven. There is a rich Kubernetes API that you also can extend to do different things for your specific environment. Also, it's large community. We've seen that there are more than 2,000 contributors to Kubernetes from different companies. So there are a lot of people helping making Kubernetes better. But there was also a business reason. So as I said, Datadog is a monitoring platform, and we saw that trend on Kubernetes being more and more popular. And we wanted to make sure that Datadog was the best platform to monitor Kubernetes and the applications that you run on top of Kubernetes. And we thought that the best way to do so would be to run it ourselves. So if we run it in our infrastructure that is very, very large, we are going to learn how it's best to monitor it, and we are going to be able to improve the product. So there was also this business reason on why we chose Kubernetes for our infrastructure. And so we are all talking about Datadog and how we are using Kubernetes at Datadog, but to put a little bit more in context, so I joined Datadog more or less a year ago. Actually, today is my anniversary, so I can say a year exactly ago. And when I was interviewing for Datadog, I was already working for the previous 2.5 years in Kubernetes projects. I was working for a vendor. We created applications on top of Kubernetes, where we were also running our infrastructure Kubernetes. So I had quite a bit of experience running Kubernetes already. But when I was interviewing for Datadog, I had the opportunity to talk to a lot of people on the infrastructure team, on the repository teams, and we discussed how they were running Kubernetes, how they were deploying applications. And for me, it was very clear that for me it was a very good opportunity to join this company and learn Kubernetes at a different scale that I was used to. And what scale are we talking about? So just to put an example, this is one of our clusters. So each hexagon that you see there is a node. It's a worker node in our cluster or a control plane node. And you can see that it's a very, very, very big Kubernetes cluster. But it's definitely not the only one that we're running. We run thousands of those clusters, each of those with more than 1,000 nodes each. And very particular, we run on different clouds. So we run on public clouds, but we are not run on just a single one. So we are a multi-cloud company. And one of the things that happens when you run open source projects and when you use open source projects is that those projects get better with usage. As more people are using them, people find corner cases, people find bugs. They may also contribute back with patches, so they get better as more and more people are using them. But what happens if you're using it in a slightly different way that the rest or most people are using it? And this happened also with the scale. So I found this survey, and it doesn't have that many respondents, about 800, I remember. So take it a little bit with a pinch of salt, but just to give you an idea. So in this survey, I put the source there of the results. One of the questions was how many nodes that your cluster having on average. And 40% of people more or less said between 1 and 5. Obviously, these are people who are still testing Kubernetes as a platform. They're not ready to move to production. Then there were a lot of people in the 6 to 50 nodes. Most of the people are there. That's starting to be more production-like environments. But the interesting thing here is that only 4% of the people who replied to this survey were running more than 100 nodes. So again, what happens is that when you run an open source project at a different scale that the majority of people are doing, you may encounter scalability issues before anybody else. And therefore, you get to try to fix those issues and improve those so before anybody else. And this is a little bit what happened. So And what are the common scalability issues that we find in Kubernetes? So there are many. There are from security to, there are many of them. But the specific ones we are going to focus on this particular webinar are the networking ones, because I think those are the most important ones. As any distributed system, networking is super important, can create a lot of bottlenecks, and Kubernetes is not different. And one of the things that people maybe don't realize before they move into Kubernetes from something else is that Kubernetes networking is not that easy. And there is a learning curve that I'm going to try to explain a little bit today, so you know at least have an expectation of what you're going to see when you move to Kubernetes. So because we are going to be focusing on networking, I'm going to give a brief Kubernetes networking 101, let's say, very high level, nothing specific, but that way we are going to be able to follow the rest of the talk. So we are going to see three concepts on Kubernetes networking. First one is pod networking, then service networking, and then DNS, particularly obviously DNS in Kubernetes. So what is pod networking? First of all, what is a pod in Kubernetes? A pod is the minimal deployable unit that you have in Kubernetes. Basically, it's just one or more containers that share the same networking namespace. And pod networking means two rules. So basically, it's just two rules that every pod in Kubernetes has. Every pod is going to get a unique IP inside that cluster. So inside a Kubernetes cluster, every pod is one IP. And the second rule is that every pod can route traffic to any other pod in the cluster, potentially. Obviously, then you can do things like networking policies to avoid some of this communication to happen. But in terms of routable traffic, any pod can talk to any pod. That is at a glance, very high level, what is pod networking. What about service networking? So pods in Kubernetes are ephemeral, are things that you cannot trust that to be there. So pod can crash, they can be rescheduled. So those IPs that the pod gets is not something that you really can trust. So when you want to talk to any of these services, for example, if your front-end service needs to talk to your backend service, instead of directly directing that traffic to some of the pods, they do so through a concept in Kubernetes called a Kubernetes service. Basically, it's a component called kubeproxy that is going to load balance traffic between the different pods of a particular service. That is basically more or less service networking. And finally, DNS, and DNS for Kubernetes. When you want, again, you're talking to those services, those Kubernetes services. Instead, you could, if you wanted, talk to an IP directly, but those IP again are dynamic, so you really don't know what they are going to be at any point in your cluster. So usually what you do when you want to talk to any of these services is to use their name service, and there is a component in Kubernetes called core DNS that is going to make that translation for you. Okay, so now that we've seen those three concepts, again, very high level, there are a lot of moving parts here that we are skipping, just to give you an idea. We are going to drill down a little bit on each of those and see how different it is when you're running Kubernetes at a smaller scale versus at a bigger scale. So we are going, obviously, to start with the first one, which is pod networking. So again, just to recap, pod networking is basically two rules about pods. Every pod gets a unique IP, and every pod can route traffic to any other pod. The trick here is that this is not implemented by Kubernetes itself. This is implemented through plugins that follow a specification called CNI, or Container Network Interface. This specification is also part of the Cloud Native Computing Foundation, the CNCF, and basically it's a spec that tells you if you want to implement one of these plugins that are going to be implemented pod networking, how you need to do it. And also not only how you need to implement one of these plugins if you want, but also how you can mix match several plugins together, because you can actually get features from a plugin, some others from another plugin. Because it's a spec and also an open spec that anyone can implement, there are tons of different CNI plugins. And the trick here, and one of the reasons why Kubernetes networking is a little bit difficult, is that they're implemented in many, many different ways. So taking into account that they have to match those two rules, the underlying implementation can vary a lot. So when people start doing Kubernetes, they usually start with plugins, like the plugins that implement overlay networks. And classic examples of this type of plugins are Flannel. Flannel probably is going to be the most classic one, and also others like WeaveNet. And usually people start with these ones because they are very easy to understand, they're very easy to debug. How do they work? So basically how they work is that these plugins create an overlay network, and every pod of the cluster is going to get an IP from this overlay network. And then they're going to create a subnet on each node of your cluster. And that subnet is going to be connected to the Docker 0 or CNI 0 networking interface, which is basically a Docker bridge. So how does it work? So let's imagine that we have a pod on the left-hand side here on one node, wanting to talk to the one on the right-hand side, a different node. So what is going to happen, these are going to be the routing table for the first node. Basically, it's going to be very simple in terms of routing table. It's going to say, okay, if the pod I want to talk to is on the same subnet that I am, that means it's on the same node. So just connect through Docker 0, the Docker bridge, and that's fine. If the IP I want to talk to is on the same overlay network but a different subnet, then go through this fake interface that Flannel creates called Flannel or Flannel 0. And at that point, what is going to happen, there is a daemon called Flannel that what it's going to do, it basically maintains a table, an etcd key value store with the different subnets and the different IPs of the different nodes. And it's going to create an extra header, an extra packet, basically an IP on IP packet, a new one. And it's going to say, okay, because this is on the second node, I'm going to create a new packet that is going to be sent to this particular second node. And it's going to send it through basically the main networking interface of the node itself. Once it reaches that second node, the second Flannel daemon on the second node is going to do the opposite. It's going to remove the extra header and it's going to reroute the traffic, the new IP packet, and it's going to reach the pod. So again, as you can see, it's super easy to understand, easy to debug, and that's why many people start with this. The thing is that when you start scaling, all this complexity of Flannel as a daemon, creating the extra IP packet, and also the extra networking consumed by it because the packet is bigger, all that, as you increase the number of nodes, the number of pods, this is start to be an overhead in networking and also in CPU because of the creation of that extra packet and removing the extra header. So when people start scaling, they usually, the first thing that they do is moving away from overlays. And there are many alternatives, as I said, because there are many CNI plugins. Just to give you an example, one that is very, very popular is Calico, that is based on the BGP protocol, which is the same protocol that is used in the internet to share routing tables. And the way it's going to work is that it's going to create one interface per pod. And because those networking route tables are going to be shared through the BGP protocol, basically every single node is going to know the next hop for a particular pod that is not on the same node. Again, this is super popular. Particularly, it's very popular for people who are implementing Kubernetes on premises. So they're running their own servers, and therefore they basically have to manage the networking themselves. But if you're running on a public cloud, like for example Datadog is, this seems to be a little bit overhead again, especially for your SRE team. So basically here what you're doing is more or less creating a software-defined network on top of the one that you already have thanks to the cloud, to the public cloud. So when you're running on a public cloud, many people are moving to things like direct routing. Datadog is here, for example. And basically, to put a couple of examples, there is the AWS plugin here and the Leaf plugin. And basically what it does is that those plugins try to reuse all the network infrastructure from the cloud instead of putting something on top. And it basically uses the same VPC that the cluster is running on, and every pod is going to get an IP from the particular VPC that the cluster is running on. And this has many advantages. The first one is that all the networking stuff is managed by the cloud itself. It matches the rule of getting routable IPs because those are IPs on the VPC, but also it has the advantage that if you haven't moved everything to Kubernetes yet, if you have legacy infrastructure on that same VPC, like VMs, for example, that traffic is also going to be routable because basically it's going to be IPs on the same network. So the first takeaway that I would say is that if you're going to be moving to Kubernetes, your operations team is going to need not only to learn Kubernetes itself, which obviously is needed, but also to learn how the CNI plugin that you choose behaves, how the community works, where to file bugs, where to find answers, etc., because they work very differently between one another. The next thing is service networking. And just a recap, service networking is basically load balancing traffic between the different pods that are part of a service through a component called kubeproxy. The good news here is that kubeproxy is actually implemented by Kubernetes itself. The trick here is that it works in two different modes. The default mode is IP tables. And this is if you don't change the configuration of many Kubernetes distributions, is going to be the default. The way it works is that we have this component called kubeproxy that is going to run on every single node of your cluster. And basically what it's going to do is going to watch the Kubernetes API for any changes, like new services that get created and destroyed, new pods that get created and crash, maybe they become not ready, etc., etc. And using all that information is going to update the IP tables in that table on the node that it's running on. So when a client pod on that particular node wants to translate that service IP, is going to do so through the IP tables table, which very simplified could look, this is an example, could look like this. So you have this on the top here, you have an IP for a service that matches a rule. And that rule is going to match a couple of rules on 50% randomly. So that's how it works. Basically, it chooses a pod randomly. And that particular random rule is going to match the IP of the pod. So again, simple to understand, simple to see. But it has some scalability issues. The first one is that the IP tables NAT table is going to grow linearly with pods and services. So you end up with a very, very big NAT table. Also, for every change, the whole table needs to resync. This is how IP tables work. So every pod that gets destroyed or not ready or service that get created, you have to resync all the table with the CPU usage that entitles. And also from a Kubernetes developer point of view, so from the point of view of the people who are building Kubernetes as an open source project, it also had some issues because if they wanted to improve kubeproxy as a component, they saw that they were blocked a little bit on the number of features that IP tables can give you. For those reasons, all those reasons, they introduced IPVS mode that was GA in 1.11, and it has many advantages. This is what Datadog is using as well. So first of all, the changes are atomic, so you don't have to resync every rule every time that you make a change. The most important thing as well is that IPVS was implemented for load balancing. It's a kernel feature that is for load balancing, so it has a lot more features for load balancing, like different load balancing algorithms, like you can choose place connection or round robin. You don't have to do just random. And also, It doesn't matter how much you grow it. It's on one complexity, so it's not going to increase the time it takes to resolve that that particular IP. So if it was GA on 1.11, which is already old enough, I hope if you're already running Kubernetes and you're running newer than 1.11, why not just using it? So we go back to this of the open source project Get Better with Usage, because IPVS is not the default. It hasn't been for a while the default. More people are using IP tables, so a lot more issues were found on IP tables and were fixed on IP tables. And this is something that happened when we at Datadog started using IPVS, that we found issues because not that many people were using IPVS. And this is, for example, just to put an example, a PR merge into Kubernetes from Laurent Bernet, who is one of our engineers who are taking care of our Kubernetes platform. And he had to actually contribute a lot to IPVS, and he became a maintainer of the IPVS implementation in Kubernetes. So something to, now it has improved a lot. This was more than a year ago, but you take the idea that if you're using something that less people are using, you end up probably finding more issues. So knowing that less people are using it, when you should move to IPVS. So it's difficult to say. You probably need to do your own testing here. But I found this load testing that Project Calico did, and both for latency and for CPU usage, it seems like if you starting at 1,000 services, it started becoming really a bottleneck. So obviously, do your own test, but something that you can use as a rule of thumb. So the next takeaway from this service networking part of it is that many large deployments are already moving to IPVS, and also they're moving to new solutions. There are new solutions being developed. To put an example, there is a quite new, well, probably not new anymore, but quite new CNA plugin called Cilium that is based on a technology called eBPF. And it also implements a kubeproxy, basically a replacement for kubeproxy. And actually, we are starting to use Cilium in Datadog as well for our newer clusters, because we found that it's super interesting what they're doing. Finally, DNS. So recap, just basically you have a service name and it gets translated into a service IP. This is all simple, it's just normal DNS, but a lot of people were finding issues. This is a famous issue that happened in Kubernetes where people were finding delays of 5 seconds at they scale. In this particular case, it was a kernel case, but people was seeing this one more frequently when they were scaling. But there were a lot of issues with the scale. So Kubernetes came up with this idea of node local DNS cache, which is beta now in 1.15, which is what Datadog is using as well. So how does it work? So basically, you create a DNS cache on every single node of your cluster. And when a pod needs to resolve a service name, they go first through the DNS cache. Through basically, and also they go through UDP, but then DNS cache to go DNS gets upgraded to GCP, which brings a lot of improvements. But it also has many advantages. One of the advantages, for example, that we have implemented in our implementation of DNS cache is that if the pod is trying to resolve a name that is not part of the cluster, for example, they're trying to resolve google.com, let's say, that is going to be dropped at the DNS cache level. And it's going to reduce the traffic to core DNS, which is a very important component in Kubernetes. So as soon as they know that it's not a name that core DNS is going to be able to translate because it's not part of the cluster, that resolution gets dropped and it gets resolved by the cloud itself. So many advantages. Okay, some takeaways from the 3 areas that we've seen today. First, kind of a bad news. Kubernetes is very flexible for developers, but it's still quite complex for operations. And I guess something that you need to know beforehand before jumping into the Kubernetes wagon. The second one is that CNI plugins work very differently. So you will need your operations team will need not only to become experts in Kubernetes, but also they will need to become experts on the CNI plugin of their choice. And just the nature of software, probably you will hit bugs, you will hit issues. So you will need to learn as well how the community works, where to find the issues, the existing ones, the release cadence for both Kubernetes and also the CNI plugin that you choose, etc., etc. But there are a lot of good things about running Kubernetes that all the bad things shouldn't stop you. The first one is that ecosystem is huge and picks up very quickly. So as we saw, for example, with IPVS or no local cache, there was scalability issues that people were finding. The ecosystem responds very, very quickly, and they create new solutions and new features to solve those issues. The second advantage is that the development experience from your developer's point of view doesn't change that much when you change those underlying infrastructure in Kubernetes. So for example, if you change the CNI plugin, for them, it's going to be the same. Which brings us to the third point, which is that you as an operations team, if you want to make those changes, they don't have to happen all at once, and they don't have to happen in this big migration project. You can just spin up a new cluster with a different CNI plugin, move some workloads there, see how it behaves, see if it's good for your use case, and then start moving workloads more and more, because basically, again, the developer experience is going to be very similar. So that's for the presentation itself. And now I would like to do a quick, very 2-3 minutes quick demo on how some of the features that we have in Datadog to monitor Kubernetes look like. And again, many of these features were built thanks to the experience that we were having of running ourselves Kubernetes and using Datadog for monitoring. So the first thing that you can see is that we have this visualization that is super useful to see all the containers in your infrastructure. And you can group them by anything that you want, like the cluster name, and filter them. And also you can use any metric to color code those specific boxes that represent a container. So for example, if we want to know which one are using a lot of memory, we can see at a glance quickly which one are those. And then we can drill down on that particular container and see which host is running, see if it's a problem with the host, etc. And then when we click on that one, we see the container list in a different way, and we can filter for any image, name, availability terms, and we can click on a particular container and see the process list that is running and how they're behaving. We can see at the same pane of glass, we can see the metrics for that particular container, but also the logs. So anything that is logged in that container that can help us find potential issues. And we also can correlate those logs with traces. So we can see all the traces, distributed traces from our application that is passing that. And also network information. We said networking is very important. We can see what other services is this particular container talking to. So you can see that obviously there is a lot more, but the good thing about running dog food in your own infrastructure is that you can help also building a better product. So that's it for now. Thank you very much for attending. We are going to open the floor for questions, and I think we have enough time. So if you have any questions, please use the question tab.
Yeah. So we've gotten a few questions in so far, but there's plenty of time. If you have a question for Ara, please go ahead and use your GoToWebinar control panel. And let's go ahead and dive into the ones we have so far. Let's see, why are you moving to Cilium for new clusters? And can you expand a little bit more on that?
Yeah, so we started investigating Cilium for its security features. There are IPsec, for example, implemented in Cilium. And once we started investigating Cilium, we found that it was actually a very good solution, and also it removed a lot of complexity from our cluster. For example, for the kube-proxy implementation that they have, or replacement that they have. So by moving to Cilium, we got the original thing that it was more security, but also we were able to reduce complexity on our own clusters. And the communication with the Cilium team has been great so far. They're super, they reply to any of our questions that we have. So it's been great.
Excellent. All right, great. Next question here. Let's see, did you try Calico before moving to direct pod routing?
Good question. We didn't. So when we were deciding what to use, we actually implemented direct routing in Datadog, and the reason is what I explained. Even though Calico was very popular, we thought that implementing Calico on a public cloud, like we were doing, wasn't the best use case for Calico. So we decided to not use Calico or any other solution similar to Calico, and use something like direct routing directly.
All right, great. Plenty of time for questions, guys. So if you do have one, go ahead and use your GoToWebinar control panel and submit it. Okay, here's one. Are you using Are you using your APM product to monitor the Datadog application running on Kubernetes?
Yes, good question. So yeah, all the applications that we run internally at Datadog, including obviously Datadog, is a little bit of inception, but that's how it is. Mm-hmm. It's running in Kubernetes and it's running using APM. So everything is instrumented with our tracing libraries, which I would like to also mention that all our tracing libraries we donated to the CNCF, to the Open Telemetry project. So if you go to Open Telemetry, you can see that many of the tracers over there coming from us. So we donated that back to the community. And yes, of course, all the applications, we use distributed tracing and using Datadog as well.
All right, excellent. Okay, next question here. Could you share some strategies on Kubernetes? The word is upgradation. I don't know if that's actually a word, but without hurting upgrading without hurting live services.
Yes, that's a very good question. So one of the things that we are doing right now is that the team who is managing our Kubernetes framework, Kubernetes platform, what it does is that instead of upgrading, because of the nature of how we're running Kubernetes, instead of upgrading Kubernetes, we give a lifetime for our clusters, and then we create new cluster with new versions, and people start moving their workloads to the new ones. So we don't do that live upgrade at least in our platform. So I cannot share strategies there because basically we don't do it.
Okay. All right, great. Plenty of time for questions, guys. Right now, that's all the ones that I've received. But if you do have a question, go ahead and use your GoToWebinar control panel and submit it. While we're waiting to see if we get any other questions, and I do want to remind the audience that today's webinar is being recorded. So if you miss any or all of the event, or if you just want to watch it again, you will have the opportunity to do so. So the webinar, we'll be sending out an email after today's webinar that contains a link to access the webinar on demand. And the webinar is also going to be on the devops.com, so you can always go find it there. You can just go to devops.com/webinars and look in the on-demand section, and it will be right there waiting for you. Okay.
Another thing that, before question, also I wanted to mention that if you want to try Datadog in your infrastructure, you can go to datadoghq.com and you can get a trial account for 14 days. That also basically the way you start monitoring Kubernetes is deploying an agent. The agent, again, is completely open source, and anything that runs on your infrastructure is going to be open source. So you can easily get the container up and running that is running the Datadog agent and start seeing how it looks like in your infrastructure.
All right, great. So what is that URL again? Datadog.com?
datadoghq.com.
Okay. All right, great. Well, we haven't received any more questions, so I'm going to go ahead and close out the question and answer period just a little bit early today, and want to, I guess, go ahead and do our Amazon gift card drawing, because I've already reminded the audience that today's event has been recorded. So without further ado, let's go ahead and do that, and then we'll just go ahead and close out today's webinar and give everybody a couple minutes back in their day. So our first winner today is Harold J. Congratulations, Harold. Second winner is Judy K. Congratulations, Judy. Our third winner is Kevin D. Congratulations, Kevin. Fourth winner today is Marvin W. Congratulations, Marvin. Fifth winner today is Mike O. Congratulations, Mike. And our final winner today is Tamara C. Congratulations, Tamara. Guys, check your inbox. The information on your Amazon gift cards will be coming to you that way. If you don't see something in your inbox, please check your spam folder. All right, great. So Ara, great presentation. Love the demo. I love looking at those demos. I think they're just so much fun. So thank you very, very much. And again, folks, if you want to do a free trial of Datadog, it's datadoghq.com, right?
Yes, correct.
Okay, all right, great. Well, thanks again for your time. I also want to thank the audience today for joining us. And this is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.
Bye.